Okay, class, in this lesson we're going to be examining states of matter. Let's first take a look at the standard that is associated with this particular topic. Georgia Performance Standards SAP1. Students will examine the scientific view of the nature of matter, which is the standard we've been studying over the last few weeks. This particular lesson, we're going to be looking at the movement of particles in solids, liquids, gases, and plasma states of matter. Now, states of matter is something that you probably remember back from when you were in elementary school. We're going to take that knowledge that we have already gained and we're going to go more in depth with the different states of matter. First of all, what determines the state of matter? The state of matter of any substance is determined by, first, the motion of its particles, how are they moving, which is what the standard wants us to be able to describe, and also the strength of the attraction between the particles is also going to determine the material state of matter. If you look here in the picture, we've got all four of our states of matter. We have solids, liquids, gases, and plasma, and you'll notice that based on how these particles are arranged in each one of these states, is going to determine how they move. It will also determine the strength of the attraction between the particles. Let's look at the solid state of matter. All right, first of all, as we're going through each one of these slides, you're going to notice that I'm going to talk a lot about the shape, the volume, the particle arrangement, and the particle motion of these different states of matter. What we definitely want to make sure we understand by the end of this discussion is their motion. That is what the standard specifically wants us to know. But the other information is going to kind of help us understand also the motion of these particles. Why are they moving the way that they are? First of all, let's look at the solid state. The shape of a solid is definite. And if you think about what definite means it's defined. It's not going to change. If I took a cube and I put it in a glass jar, that cube is still going to be a cube. It has a defined shape. The volume is also defined. If I took that same cube and put it in that glass jar, that cube is going to take up a certain amount of space in that jar, which is what the volume is. How much space does this object take up? Well, solids have a defined volume that does not change. Particle arrangement. The particles are packed closely together. And if you look here in this picture, you can notice how closely packed together these particles are. And since they are packed so closely together, these particles are only able to vibrate in place. That describes their motion. So you can't really say that the particles of a solid state are not moving. That's not true. They're so close together that they are actually vibrating in place. That's all that they have the capability to do. Liquid state. All right, let's look at the liquid. Now, when you think about liquids, water, soda, milk, and of those things, they don't really have a definite shape. Typically, liquids are going to take the shape of whatever container you put them in. So for them, for the shape, we just say no definite shape. The volume, however, is definite. Just because they don't have a definite shape does not mean that they don't take up a certain amount of space in whatever container you put them in. So if I took 50 milliliters of water and put it in a glass, it's still going to be 50 milliliters of water. Even if I moved it to a different container, it's going to keep its same volume. Particle arrangement. The particles are close together. If you notice here in the picture, they're close together like they are in a solids, but what do you notice different here about these particles? If you said that the shape is different, then you're correct. If you remember back at the solid picture, the particles kind of formed a shape. They had a definite shape. Well, liquids don't have a definite shape, all right? But they are close together, okay? They are close together. Okay? Their motion. The particles are able to move around freely. They have enough energy to move out of their fixed positions, but not enough to move very far apart. So all of these particles are they're more spread apart from each other than they are in a solid. They can move freely, but they don't have enough energy in order to move too far away from each other. All right, let's take a look at the gas state. Okay, gas state. No definite shape, no definite volume. Gases, they're pretty much, their particles are bouncing around all over the place. Okay, so they will of course take the shape of whatever container you put them in. and they'll have the volume of whatever container you put them in. All right, there's no definite volume and no definite shape for gases. They are very far apart from each other, much further apart than those in solids and liquids, and their particles are going to move at high speeds in all directions. They move at high speeds in all directions. All right, plasma state is probably one of the states of matter that you may not be as familiar with as you are with the other ones. It's kind of a unique state of matter, and it's not one that you've learned about probably in years, but we'll learn about it this year. First of all, what we've got to remember about the plasma state is that it occurs at extremely high temperatures, and it's very common in the universe, but it's not common on Earth. Plasma states are formed when you take a gas. Plasma states are actually just a gas state of matter heated to a very high temperature. But it's heated to such a high temperature that the electrons that are part of the atoms in that gas, they get enough energy that they can escape those atoms. And we talked about the atoms when we were discussing structure of matter, and we know that it has electrons. Well, this gas gets so heated up that those electrons are able to escape from those atoms. So that's very, very high temperatures. Of course, plasma states, they move at speeds higher than gases. We talked about gases move at high speeds. Well, think about if you take that gas and you heat it up to a very, very high temperature, it's going to be moving even faster. Some examples of the plasma state, which is something that plasma state is one that we're not that familiar with, would be stars. For example, stars, as you know, is just hot gas, and that is considered the plasma state of matter. Lightning, okay, which is one that we experience here on Earth, would also be considered the plasma state of matter, as well as the sun. The sun, which we know is a star as well, would also be considered the plasma state of matter. And as we explore these states of matter more, we are going to find more and more examples of the plasma state, which is one that we may not be that familiar with. But just remember, it is a state of matter that will occur at extremely, extremely high temperatures, which is very common in the universe, but not very common here on Earth. That concludes our lesson on the 4 states of matter.